Okay, most of the stuff you're doing here in this chapter is to do with knowing about differentials and very special differentials and using integration by reversing things that are recognised. Um, Now, the techniques they show, they do quite a lot of guesswork in, and I'll probably show you by substitution at some point. So what happens here is we've got the formula booklet with standard differentials and standard integrals. And the sorts of things they might ask us to integrate are sets of fairly standard ones. Now, we did a special lesson on differentials for exponential. So things to actually remember and learn are things like the differential of log of x is 1 over x. And we can do the other way to remind ourselves that we've got the integration. There's also some things where we've got to know the basic trig ones as well. And the way to remember those ones often is do a quick sketch of the gradient. So sine does this. And what you find out is the gradient here is 1, gradient here is 0. In between, it's actually falling quite quickly as we get towards here. And what you wind up with the gradient doing is actually a cosine. So knowing the differential of that, when you differentiate the cos, you of course get the minus sign. So you get sine goes to cos, goes to minus sine, goes to minus cos, and going round that on the clockwise direction is what happens when you differentiate. So it's knowing those and reversing them are the keys to these steps. So I'll go through a couple of the ones in the formula booklet so we can find out values that will work out for us. So if we start with the integral of a function 2 cos x plus 3 over x minus the square root of x, and integrate that with respect to x. Well, each of these becomes its own integral, because the area from this part, and the area from this graph, and the area from this graph all get summed together to create the area under the curve. So they can be integrated separately. So the first thing we've got to do is do the integral of 2 cos x with respect to x. And we know from using this that if I've got a cos, it integrates to a sine of x. The coefficient can be taken outside, so the 2 stays around. Anything you multiply, if it's not needed inside, you can take outside of the integral. And there's a constant, and there's a constant going to be for all the ends. So all of these bits are going to have the same resulting constant. Next one, write it in index form. So we've got 3x to the minus 1 with respect to x. Integrating, we're going to get the 3 come out. We get x, and this is the log. Actually, we can go straight to our differential. The 1 over x part, we get 3 lots of 1 over x. When we integrate, we come back this way to the log. So this is going to be the log of x. And integrating my x to the half is going to give me x to the 3 over 2. And of course, when we integrate with a power, we divide by the new power for a polynomial. So there's my 3 terms, and my final integral is going to be 2 sine of x plus 3 the log of x, and this is a modulus function, not just a bracket, minus, this term has been subtracted, minus 2/3 the square root of x cubed, and a constant on the end for the whole expression. That's their first example, slightly different explanations, but where information comes from. Example 2, we've got an integral of cos over sine squared x minus 2ex. And again, we've got to do it as two separate integrations. We've got, let's just have a look at the stuff we've got here. What we actually have is cos over sine is cot x, and 1 over sine is cos x. So that's what that becomes. And if we look over here, we've got a cos x cot x is minus cos x. So when we go from that one to that one, we get integration. So we can use the standard differential. So this one, when we integrate, we're going to get a minus in front of it. And it does need that minus. So we've got minus cos x cot x, which is that one, which is what came from this trig ID. And that is going to give me minus cos of x. So we've expanded that one out. The second part, we've got a 2e to the x, and by definition, e to the x always goes to being e to the x. So we're going to get a 2 from the multiplication. It's being subtracted as well up there. So this just gives us 2e to the x, and both of these need a constant again. So we've got a minus cos x minus 2e to the x plus some constant is their second example. Third one is one where they've actually given us logs and we need to work our way through. And I need to bring this down with me, so let's copy that. Oops, I'm just drawing on it. Let's move that one forward. No, I don't, because it's a log one. It's going to be 1 over x. Just had a look at the question. So the third example. Example 3. They want to do the integral of 3a from a of 2x plus 1 all over x with respect to x. And what we have in here is we can expand it first. Don't forget that you can expand these into simpler forms. So 2x over x, the x's cancel, and 1 over x is the thing that's going to give us our log. That's the one that we need to learn. Okay, so differential of log x is 1 over x. So we integrate these, and we get 2x divided by 1, and we get a log x for 3a and a, which is going to be 6a minus 2a plus log 3a minus log of a, and we were told that must equal log of 12. Now the a's give me a 4a. Log a of 3a minus log of a, we can also say as the log. Remember that logs, when they come along, we've got our log rules. Log of a minus log of b is the same as the log of a over b. So that's what we're going to put in. So we've got that is a over b, which is 3a over a, which is log of 3. So 4a plus the log of 3 equals the log of 12. Again, go through, separate it over. and we get 4a is now, so they should be equals, not when I'm rearranging. So take that one to the other side, it's going to be subtracted, it's going to divide, so we can get the log of 4. So our value of a is 1/4 the log of 4, and that's by substitution. I'm going to show you a little technique that gets around some of the stuff you've got to do in the other ones for finding when k, if you differentiate kx, you get a k come out. But I'm going to show you a technique. I've decided I'm going to show you integrating by substitution. It's a P4 topic, you will need to know it anyway.